for everybody who joined us in the last few minutes. Thank you again for choosing to attend this talk with us. I think we're very excited to present this to you. We have some slide content as well as a live demo to show you today. So I'm hoping this will be a good conversation, and hoping that we get a lot of questions back from you in Q&A so that we can make this most valuable to you. If we don't get to your question as part of the presentation, we'll definitely be sure to reach out after and follow up with you. All right, so with that said, let's get underway. So the topic for today is we're talking about enhancing security operations with automated threat analysis, right? And before I really dive into the content, let me start with a quick introduction. So I lead product management for Splunk Attack Analyzer here at Splunk. And I've always been passionate and taken a lot of pride in building products that are loved by practitioners as well as leaders alike. So what I mean by that is I really care about how the folks that are using the product with hands-on keyboard feel about it, as well as how leaders or executives at the company feel about the value that it delivers to their teams and helps improve their overall security posture. With that said, like for the topic today, like I do intend to just start a little bit with some background on like what I think are some of the gaps in our TDIR processes that are potentially preventing us from achieving greater automation and greater gains in those processes from an efficiency standpoint. I would like to show you a demo of how you can, make this, or how Splunk security products can potentially make this easier for you. I think some of the concepts apply irrespective of what stack you're currently running and what tools you currently own from Splunk versus not. So I think you'll get a lot of value from the discussion, but the demonstration will go through a bunch of Splunk products showing you exactly an example of how we can help you improve automation in your TDIR process. Would like to take all of your questions. Please keep them coming throughout the presentation. And then, we do want to continue this conversation post this session, and we'll outline some next steps that may be logical follow-ups for us to take here. All right. So let me start with a pitch on why you should care about this presentation. What I'm hoping to deliver today are some practical ideas to help you and your organization progress in your automation journey on the TDIR or security investigation front, right? If you were to start mapping out your automation journey for TDIR, right? What you would need, right, is you'd have to have a way to find out about things that are happening in your environment, which I'm calling auto detection on my slide here, right? You'd have to have some way of finding out, something is going on, right? Next step here would be, hey, I need to go actually investigate that thing and figure out, is this something that deserves security attention and deserves, remediation or follow-up action? Or is this just pure noise that trickled in through my detections because I tried to make them comprehensive, which meant I cast a wide net and got some things which were maybe not truly security business, right? Once you've conducted that investigation, you then want to figure out, all right, so I know this thing is bad, and I need to go clean it up across my environment and make sure that it doesn't cause a problem for my organization. And that's where containment comes in. And then lastly, you want to take a step back and say, all right, this thing went through or came through into my environment. My systems did detect it. I was able to investigate it, contain it. But how do I make myself better or have myself better protected from a similar type of threat going forward? So this is the part where you take a step back and just figure out, like, what do I need to do better going forward, right? Now, layering on automation within these 4 stages, I'm sure these 4 stages are fairly, look fairly familiar from a, standard incident response plan, framework perspective. If you look at sort of automation and the role of automation within these 4 steps, I think most organizations would love it if they had a system that was automatically able to detect all critical security events, investigate them, filter out what is noise versus what is truly a security threat, take appropriate containment actions based on the IOCs found in things that are actually a threat, and then reinforce their environment so they're better protected against this type of a threat in the future, right? So if you were to think about like where most organizations would like to be, they would probably say something like step 4, right? But realistically, for various reasons, and not belittling the challenges involved here by any means, but most organizations find themselves even slightly behind step one, right? And the reason is, if you want to achieve comprehensive detection, it suddenly comes at a cost of like, how much noise am I going to be sending through the system? How can I filter through that effectively? And then steps 3 and 4, which involve containment and reinforcement, require you to have actionable IOCs that you can go act off of, and a signal that you can trust in order to take some of those containment actions, because they could break end user workflows to some extent. Like, you don't want to block out an executive's account over a false positive, right? Like, that would usually lead to bad outcomes for everybody involved in that decision making process, right? Which is why we haven't made as much progress in this area as we would like to, right? And just summarizing some of those challenges again, like if I just place that in a crisp sentence, attackers are not making your life easier, right? So you're stuck in this constant cat and mouse game where they're finding new innovative ways of targeting your company. Across with all of the tooling that you have across your organization, you're still stuck with limited visibility and context because there's so many different technologies that are in your environment, and not all of them may provide you complete visibility into a particular attack that you're looking at. And then lastly, you don't have people to even do the sort of day-to-day investigation and response tasks that are on your hand, let alone be able to take a step back and figure out, like, how do I get out of this broader sort of whack-a-mole situation, and take a step back and say, how can I automate my TDIR process at large, right? So that's sort of what makes this super, super challenging, and which is why we haven't really reached stage 4 across most organizations that we speak with today. Let's take a more constructive view on this, right? So we talked about where we would like to be. We talked about why it is hard. Let's take a constructive view on this and say, what would have to be true if I wanted to get to step 4, right? And that's something that I've really, really been thinking hard about. And I've arrived at a particular viewpoint or a point of view. Very keen to hear how you feel about it, right? So if I want to achieve auto reinforcement within my environment, right, my TDIR stack or my security pipeline must be able to detect potential events with comprehensiveness. Now, comprehensiveness comes with the cost of plumbing a bunch of noise through my systems, right? Which means I need a trustworthy investigation layer that can yield IOC level granularity for things that are actually bad and need containment or reinforcement. But I also need an investigation layer that I can trust to filter out noise and tell me what is not security business, right? Thirdly, there is the containment piece, where you must have the ability to locate all of these different IOCs that were discovered as part of your investigation across your environment, and then hooks to perform remediation actions in terms of, hey, go block, go remove this particular email that may be in somebody's mailboxes, go remove this particular file that somebody has access to, go block a URL, so on and so forth, right? And then lastly, there is the piece around reinforcement, where you must have the ability to block the same or similar breach from happening in the future, and learn from these attacks to mitigate risk going forward. If you look at Splunk's security product portfolio, I think our TDIR stack really gets you there, right? And if I think about how, right? So let's talk about the detect piece, right? Enterprise security has hooks into all of your data sources, and our regular content updates ensure that you're detecting events comprehensively as they're happening across your environment, right? The second piece, which I'm sure very few of you are probably familiar with, is Splunk Attack Analyzer, right? Which is the product that I own here at Splunk. It is really that missing piece, or that bedrock that you can help build your journey towards auto reinforcement based on, because it is a high accuracy investigation signal that can generate actionable evidence for you to perform containment and reinforcement, while also help you filter all of the noise that you generated from a detection standpoint, because you wanted to be comprehensive in your search for potential events, right? Then we have Splunk SOAR, which is connected to all of your enrichment as well as enforcement points, and helps you figure out what are all the containment actions you need to take based on the evidence generated by Attack Analyzer, and actually helps you go and execute them, right? And then all of these tools come together in various ways to help you improve your broader security posture by taking a step back about how attackers are targeting your organization or your environment, right? So that's sort of what I think is the key piece here, right? Which I think investigation, or the quality of investigation, makes all of this a success or not, because if you have a reliable signal, you can proceed to containment and reinforcement, but you can also ingest a lot more, or you can bring a lot more detections at the top of the funnel because you have a reliable signal that can help you filter signal from noise, right? So with that said, let's jump into a demo here. And what I want to show you is, let's imagine I'm in a situation where I have a phishing email that has somehow made its way into my organization. I want to show you Splunk Attack Analyzer as an investigation signal to some extent, right? Won't spend too much time on how the detection happened, but a common source is like, employees reporting emails. Anybody who's ever worked within a security organization knows that that's a super, super noisy signal, right? Like 90% plus of the emails that employees report as suspicious tend to not be security events, right? And need to be filtered out by an automation or an automated investigation solution, or an automated analysis solution. Otherwise, it just creates undue burden on the security team to go investigate a bunch of junk to find the signal within that small signal within that noise, which could actually be an event that leads to a breach, right? So I'm going to walk through that phishing email example. Let's imagine for now that it came through from an employee reporting that email. It could have also come through some searches that were being correlation searches that were being run in enterprise security, or notables that were being generated there, and so on. So various paths of getting there. But it's something that we like is a good example to just walk through, like a high noise detection signal that you need to filter through, and then when you find a true security event, you need to contain very broadly, because each email doesn't just, like, the email is not the problem alone. Like, there's probably URLs or attachments, etc., in that URL, which then cause further problems for you throughout the organization from a containment as well as reinforcement standpoint. So I'll go ahead and share my screen, and then let's walk through let's walk through the example here. So here's an email that I'm initially just showing you the email and what we are actually investigating. So let's pretend for now that this made it through to my organization and went past my primary perimeter defenses. It's called Splunk T-shirt company integration testing.eml. This is the Attack Analyzer UI that you're looking at right now. You see that Attack Analyzer has assigned a score of 100, a verdict of a phish, and a malware family, and a couple of brands that are being impersonated here. Let's actually take a look at the content. So here's the email that we are investigating in our environment now. So what came out of Attack Analyzer? The screenshots show you the following, right? So it's an email that says, hey, we're testing a new integration between Splunk T-shirt company and Buttercup Security. Provides you a code to access the attachment that's involved here. The reason that they're doing that, where they have introduced a layer when they send this email to Fyodor, is that they just wanted to make sure that security scanning at the perimeter just declares this safe, because ultimately until you open the attachment with this password, there's nothing inherently bad about this email on its own, right? Next step here, of course, is to go traverse that email, look at the attachment, and figure out like what's contained in that attachment. And that's something usually a manual human analyst would have to take as an action. However, in the case of Attack Analyzer, it's intelligent enough to traverse down that tree pretty much like a human analyst would, right? So it's able to go and look at, hey, here's this PDF, it has this password applied to it, so I need to go decrypt it. It's able to go do that, and now start looking at the contents of the PDF, right? And here's what it sees. So it says, hey, here's a Splunk T-shirt company employee, Splunk T-shirt company branding, a branded QR code, and a Microsoft logo on an example that, or on a PDF that clearly looks to not be coming from Microsoft, right? So here's something suspicious about it. So at this point in time, Attack Analyzer starts, giving it, or has some detections on it, which give it a score of 75. It's still not the full 100 that we saw at the top of our screen, which probably means there's more bad stuff found further along the investigation chain. However, there is a initial indication here that this thing might be bad. Notice the red exclamation mark here indicates that this is a potential resource, if found within your environment, is potentially one you want to put on top of your remediation queue to figure out, like, hey, who else has accessed this, so on and so forth, and potentially contain by blocking it at various points within your environment. Next logical step, as part of your analysis here, would be to go follow the QR code to see what's at the other end of that QR code. So Attack Analyzer does that again. This website again poses a blurred out content piece, which you need to click before you can access. Again, a common technique to get past security scanning. Attack Analyzer is able to render the content beyond that. One of those links now leads to a mobile login page. The other one is a download with a password provided here on the website. Again, Attack Analyzer traverses both of those paths. This one leads to a Microsoft phishing page quite clearly. There's now a whole host of detections on these with the final score of 100. It says, hey, I saw a Microsoft phishing attempt because I see a background image resource that's commonly observed in phish kits. I see a email password form that's commonly used in phish kits, et cetera, et cetera. And rightly so, this resource has a red exclamation mark on top of it. The other chain happens to be a zip download, and as you go past that zip download, it actually leads to an executable, which again, Attack Analyzer through its sandbox is able to attribute to the agent Tesla XOR, malware family, and has a bunch of clam hits against, right? So that's the threat that we're dealing with. The things that are remarkable here, right, like, is Attack Analyzer as an investigation signal is able to traverse that entire attack chain in an automated manner with no human intervention, exactly like a human analyst would, and logically follow that sequence of steps. It's able to tell you, here are the 4 things that you may want to look for across your environment from a containment standpoint, and then give you logical steps to proceed further in your automation journey. Now, let's bring it home. So this is the attack that we're dealing with, and the results of the investigation that came out of Attack Analyzer. Up until this point, you could achieve 100% automation, right? Now let's bring it home and talk about how to leverage this signal to go further beyond automation and now move closer to containment and reinforcement within my environment, right? And the way that works, I'm going to pivot over to Splunk SOAR here, right? So Splunk SOAR has an app for Splunk Attack Analyzer that you can connect in. And I'm just going to show you what that app looks like. So I'm going to search for Splunk Attack Analyzer here on my apps. I already have this app installed, but what I wanted to show you here is there are 9 supported actions that this connector allows. And if you look at one of those actions, that's detonating files, right? That's how this particular email makes it into Splunk Attack Analyzer for analysis. It also is able to get back some information from Attack Analyzer about its analysis, and we'll talk about how that fits in. But this is the connector that ties Splunk SOAR and Attack Analyzer together and helps you go from, here's this rich investigation signal, to now let's take containment actions by finding where this has happened in our environment, right? And for that, we also provide a default playbook for automated email investigation that leverages Splunk Attack Analyzer and has modular components that you can use to follow the logic blocks to say, hey, here's my incident response process, and here's why it makes sense, right? So I'm just actually going to search for email here and find that playbook. So the playbook is called Splunk Automated Email Investigation. It's published to the community by Splunk. And if we take a deeper look at it here, and it'll take a few seconds to load, but what I want to highlight here is just how modular and logically easy it is to follow, right? So let's say you're trying to conduct incident response on this specific email that you're looking at, right? First thing is obviously, you want to get that email, you want to submit it to Splunk Attack Analyzer for analysis. No surprises there. Then you want to get back the results of the analysis from Splunk Attack Analyzer and follow a certain set of steps, right? So first thing to do is figure out like, hey, how many bad URLs did I see in this attack chain versus how many bad, emails versus how many bad files, et cetera, et cetera. So it just splits out the URLs and the files here. And then it asks the next logical question that you would ask as part of your incident response, which is, who interacted with these URLs? Like, who do I need to worry about, right? Same question for files, which is like, who interacted with these files? Like, who do I need to worry about, right? And those are the people that have potentially active signs of infection that you need to go contain. But there are potentially latent users who have this email or exact same or similar looking email lying in their mailboxes, but have not yet been infected or interacted with any of the content, right? That's a potential latent infection waiting to happen, right? So you want to go clean those up as well, right? So we have these playbooks. What they're essentially doing is taking the data that you already have in Splunk with your proxy or SWIG logs or your EDR logs or with your secure email gateway logs that are making their way into Splunk and running Splunk queries to go figure out who interacted with URLs, who interacted with the files involved that are malicious, and who actually received this email to begin with. Taking all of this information then helps you get a better understanding of what the spread of this infection within your environment may look like and facilitates appropriate containment actions going forward. So let me switch back over to SOAR and just show you an example event here of an email. And this is exactly the same email that we were looking at earlier in Splunk Attack Analyzer. So it's the email called Splunk T-shirt Company Integration Testing. If we look at some of the artifacts, we have an email artifact in the in the event here, right? And it's obviously an email that went to Fyodor, exactly like we saw on Splunk Attack Analyzer, from Jessica Jones. And this is an email that I would want to execute, a playbook against and figure out like what has happened, right? So I'm going to go run that same playbook we were just looking at. So I'm just going to search for email again. And there it is, the playbook, which is Splunk Automated Email Investigation. I'm going to hit run playbook on that. And it's going to do a few logical steps for me. So obviously, the first thing that it did is it submitted this email to Splunk Attack Analyzer for dynamic analysis, which in turn, detonated that file, provided a summary output as well as screenshots back to SOAR. And then, it's now trying to find some additional activity associated with all of the things that, we had seen as part of that attack chain, where it's running a query for that file to see, hey, who has interacted with this file, who has this message, and again, who interacted with this specific URL in your environment. And it populates all of that information back into SOAR directly for you here, right? So if I switch over to the notes section, I think it's very easy to follow that, right? So essentially, you're seeing here a note that summarizes the entire investigation and the recommended containment steps for you. So first thing is it says, hey, this was the email that was submitted for analysis. It scored malicious, and it was classified as a phish. Here's a link back to Splunk Attack Analyzer in case you'd want to inspect it any further. Provides you all of the screenshots that we were looking at earlier. So here's the QR code PDF. Here's the phishing page, all of the obfuscation, and anything that happened in the sandbox as well, right? All of that information is provided back to you here, so you can make a quick judgment on like what I need to do. But it goes well above and beyond that, because what it does is then it says, hey, I saw 2 bad URLs in it. And SOAR has already gone and searched your environment for, or by running Splunk searches for who may have interacted with this particular URL. And while Fyodor may have reported that email, we see another user, which is Shelly Kornblum, who actually interacted with both of these URLs and could potentially be compromised, right? So you see this information coming back from your Splunk searches straight into SOAR. The other thing to look for is hey, did anybody interact with any of the files that were part of this investigation that we scored high, right? And you do see that there was a particular file that again was interacted with by Shelley in this specific example here. We also get an IP address associated with that, and so on and so forth. Lastly, it looks for who has this email within my environment. There's not many surprises that come out of that in this specific example, because we already knew Fyodor had that email in their mailbox, and Shelley also had this email in their mailbox, which is why they probably interacted with all of this content here. So as a logical next step here, right, what you want to do is, let's take a look at some of those artifacts, right? So we have had certain URLs that were interacted with, and we know that this is a potential URL that we need to go block across our environment, because we don't want more people accessing this URL. So you can pretty much hit copy here and click the run action button, and then under that you'd look for an action like block URL, and that will just allow you to select whatever connectors you have in place to block your URL. Let's say I have a Zscaler as my SWIG, and I can paste in this URL and say, hey, I want to add this entry to my block list, right? And what you're going to see here is it's actually going to go and do just that. So I initiated a user-initiated block action, and it updated this URL to be part of my Zscaler block list. Now, while I did this manually here, you can very well extend that playbook to actually go take on an automated block action based on what the risk to productivity versus risk to organizations, risk to the organization being attacked trade-off looks like within your organization. Attack Analyzer provides you a signal that as long as the score coming back from Attack Analyzer is 70 or higher, you can definitely go and take some of these automated containment actions. One last piece that I'd like to call on here, right, from a containment standpoint, is I do know that Shelley potentially interacted with that phishing URL, right, and could be compromised. So another thing I probably want to do is disable Shelley's AD account so that there's no malicious activity from the compromised user account that an attacker has gotten hold of, right? So I can go hit disable user, go to Azure AD, and then populate in Shelley's email address. But to do that, I would have to copy that email address, which I did not do earlier. So here I'm just copying that and doing a do-over. So disable user, Azure AD, and then block this email address and hit launch. Now that's going to go and disable the user account so that they're not a problem for my organization in case they have successfully been breached and an attacker has gotten hold of their credentials. I hope that helps walk through some of the containment as well as reinforcement pieces. Like, nobody will be able to access this URL going forward. This specific user who's been compromised, their Active Directory account is now disabled, so you can work with them to figure out like what do we need to recover if there's any other problems. You can also go do things like isolate hosts if they were running malware, et cetera. Logically, I hope that makes sense in terms of how you go from automatically detecting from a noisy signal, which is employee reported emails as an example, where you may have 90% noise and 10% signal. You're automatically detecting that this is something that needs investigation. Attack Analyzer conducts all of that investigation pretty much like a human analyst would in an automated fashion, walks that entire tree. At the end of that tree, it generates back information to say, hey, here are the 4 things that we need to look for across our environment, and we need to make sure that we are containing against as well as reinforcing our environment against, so that we're not vulnerable to a similar attack going forward. And that's the end-to-end demo here, right? Where I just wanted to show you this example of, here's a phishing email that got through your perimeter defenses. How can you reach a state of auto reinforcement with an example like that? Summarizing the key takeaways again, right? So I think having a trustworthy automated threat analysis or investigation signal is really key to making progress in your automation journey. If you can trust that investigation layer, you can first throw more stuff at it from the detection layer and also take more actions from a containment or a reinforcement layer standpoint, right? That really is the fulcrum that all of this is built on top of. Splunk Attack Analyzer is a tool that serves as that strong analysis foundation and helps you further, your automation as part of your TDIR process, because it's an investigation signal that's going to pretty much follow the same steps as a manual, highly trained analyst would, and give you a strong signal that you can feel comfortable filtering out noise off of, as well as taking containment actions off of when you're dealing with a threat. And then ultimately, across Splunk's TDIR stack, you have all of the components that are necessary to achieve a state of auto reinforcement where you can generate detections from enterprise security, have a strong investigation signal from Attack Analyzer, and then take appropriate responses from a from a SOAR standpoint. I hope that demo made sense and tied all of those pieces together. At this point in time, I think we're open to. Oh, sorry. Before we open up to questions, I know Attack Analyzer is, I think, the newest part of our product portfolio that many of you may not be very familiar with. So did want to leave these resources out there for you. So there are a bunch of additional resources that will help you get more information on Splunk Attack Analyzer, as well as how Splunk Attack Analyzer fits in with Splunk Enterprise Security, with Platform, with SOAR, etc. So leaving these resources out there, for you, just so they're available. And then at this point in time, I'd love to take some of your questions and chat through what some of your thoughts were. Just looking through the list here, Casey, if there are any that jumped out at you as you were watching the Q&A box, happy to prioritize those as well. Awesome. So I'll just pick the first one that I see here while we wait on any other inputs. So what about Splunk ES? Can it be connected to Splunk ES instead of SOAR, right? So Abdul, I think that's a great question. There's a couple of angles to that, right? So first thing, right, if you think about what data exists in ES today, anything that requires a URL to be investigated can directly be connected through ES into Splunk Attack Analyzer, right? Because the URL is in your logs and completely available. So we can just take so we have an app and an add-on today that automatically just connects Splunk Attack Analyzer into ES, allows you to take adaptive response actions that submit URLs over to Attack Analyzer for analysis and plugs the results of that analysis back into ES. We also have like a right-click manual workflow action that you can take to submit a URL you're investigating to Splunk Attack Analyzer for analysis. That does require that you have access to Splunk Attack Analyzer as a user to submit that. But that is something that we commonly see customers using and we're able to do. But Attack Analyzer is, if you think about like alerts that you're investigating across your TDIR stack, there are some that involve URLs, and then there are others that involve files. Like for instance, alerts that come from your EDR probably involve files. Now most customers, and I assume you're no exception, do not have that complete URL directly available within Enterprise Security, right? That complete file available within Enterprise Security. You're not pulling all of that into your logs. So that's where you can tie Enterprise Security, SOAR, and Attack Analyzer, all three together. So you have a alert that fired off in Enterprise Security that alerted you to the potential presence of a bad file in your environment. You ran a SOAR playbook to go retrieve that file from whatever endpoint it exists on, or if it's in a quarantine store somewhere. You went ahead and retrieved that file, submitted it to Splunk Attack Analyzer, and then traversed down that tree exactly as we were talking about, right? So anything to do with a file, you would need SOAR plus ES plus Attack Analyzer involved in. When it comes to URLs alone, you could get away with just doing ES plus Attack Analyzer. Obviously, having SOAR in that mix will help you do a lot more containment actions than just ES and Attack Analyzer would. But it could be a starting point for you in your journey. I hope that was a helpful explanation in terms of the question that you had. Feel free to follow up if there are other questions or other areas that I did not completely address. Wendy asks, is Splunk Attack Analyzer only available with SOAR, or is there a plugin or add-on for Splunk? Yes, I think, Wendy, this is very much in line with the question that I just answered from Abdul, right, where we do have an add-on and an app which installs onto Splunk platform and enterprise security and allows you to take adaptive response actions against URLs, etc. Combined trifecta helps you do a lot more from a containment standpoint, as well as helps you investigate files as well, which actually have to be retrieved, which SOAR has the hooks to go retrieve. Matan asks, can we use Splunk Attack Analyzer without SOAR? Can we integrate it into Splunk Cloud or Enterprise? And I think, Matan, like, absolutely, you can use Splunk Attack Analyzer without Splunk SOAR, right? You can integrate it into Splunk Cloud or Enterprise. You can submit URLs through it that way. For other things, we also have folks that manually upload files or emails into Splunk Attack Analyzer for analysis. Like, our UI does support that. We also have integrations with, like, if you're looking at some of the email specific use cases, we also have emails with, like, popular email reporting plugins where you can just plug in our unique email address and have things submitted to Attack Analyzer that way. So definitely a tool for the SOC that you can use via manual UI uploads, via manually hooking in your API integrations for various use cases, but you also have adaptive responses as well as manual response actions in Splunk Enterprise Security and Splunk Cloud. Great question, though. All right, so Kent asks, as part of your auto response, could you also do an impact analysis before executing the remediation? For example, could you do an analysis to see if the URL you are about to block has been used in the past by your organization to determine if blocking it will have any business impact? Ken, that's an amazing question, right? So I think definitely don't want to block google.com, right? Like we've all had or at least heard stories of an event where somebody blocked a business critical resource to your organization. That's definitely a block we can add into that playbook there. As long as you have your Swig or proxy logs flowing into your organizations, into Splunk, you can have all of those results pulled back as another query, and counts and aggregations on top of that are definitely a very easy thing to add on there. So you're not just taking action blindly, but validating that you're not going to cause a problem for your organization by doing that. So that's a fantastic question. All right, so we have Andrew who asks, is SAA new? Does it have greater functionality than any other email tool such as Proofpoint? Andrew, that's a great question, right? So the way to think about Splunk Attack Analyzer, yes, it is a new tool, but the way to think about Splunk Attack Analyzer is more like an automated threat analysis tool for the SOC that goes well beyond email, right? So email is one use case for it, but it is any sort of file or URL that your SOC team needs to investigate. When it comes to overlap with Proofpoint specifically, right? I think there is a use case around employee reported emails that we definitely have potentially some overlap with Proofpoint on, where they also offer solutions in this area where you can submit employee reported emails to us. But our sort of capabilities at being able to traverse the entire attack chain and render analysis on what's behind that QR code, render analysis on, like, hey, what is this executable leading over to, or what is this website, which fish kit does this website look like, etc. Makes us stand out from an efficacy standpoint. So we're able to detect more stuff because firstly, we're able to get to the right stuff that needs to be analyzed, and also perform deeper analysis on it than some of your perimeter optimized tools like Proofpoint would. So that's sort of how SA and Proofpoint fit together. I hope that explanation was helpful. It's more of a SOC analysis tool than a perimeter email protection gateway. And being a SOC analysis tool, it can go a lot deeper because it's not trying to analyze absolutely everything that's hitting your perimeter. Sifiwe asks, how long does Splunk automation take, and can it have issues while you in the process of automation? That's a great question, Sifiwe. I think most analysis results come back in the order of I mean, it obviously comes down to the complexity of the attack chain, but most analysis come back in the order of seconds to minutes, right? It's not something that we're like I said, it's not a perimeter defense type of technology. It's a SOC deep analysis tool. So we optimize for being thorough and being right, so that you can take confident containment actions based on it, rather than trying to be super, super fast. So it is not like a long wait, but it's like the order of seconds or minutes that we come back with results on, right? So it's not something that takes forever, but it's not something that we are trying to build as a perimeter layer by any means. I hope that helps. And sorry, the second part of your question was, does it have any issues when you're in the process of automation? I would say not at all, right? Because firstly, it's not a very long wait. Also, our Splunk SOAR supports like logic loops, which is a functionality that allows it to, in an optimized manner, look for a response from Attack Analyzer once it has completed its analysis. So if you're using the broader Splunk stack, it's definitely not a problem. And even outside of that, as long as you have reasonable weights and backoffs, shouldn't be a problem at all from an automation standpoint. Vanessa asks, we currently have security essentials. Do you have to have enterprise security to use SAA or SOAR? Anything similar to SAA for security essentials? Vanessa, I'll be honest with you. This is one that I'll take as a follow-up. I'm not as well versed with security essentials at my end. Most of the folks that I've spoken to have enterprise security or SOAR as the primary tools that they're using. I will follow up with you after this webinar just to talk about what security essentials would look like. But as long as you have a file or a URL that needs analysis as part of your SOC processes, which I'm assuming you have in your environment, this is a tool that can add value for you. Even if there's no direct integration, they would see value by manually uploading files or URLs into the UI and performing analysis like that. We also support interactive detonation of URLs as well as files. So that's another area that you could benefit from. So, but I'll still follow up with you offline to talk a little bit deeper about security essentials once I've learned more. Scott asks, have you been doing an accuracy comparison between Attack Analyzer results and human investigation results? So at a certain score, for example, you feel pretty good about the results. And Scott, this is again a great question, right? So obviously, any sort of analysis you're doing, whether it be human or automated, isn't 100% perfect. But I would say Attack Analyzer is as close to being accurate as you can get, is sort of our experience across our customer environments. So what some of our customers tell us is, hey, if I compare Attack Analyzer to my SOC environment, right? To my SOC team, right? I have tier 1 analysts, tier 2 analysts, and tier 3 analysts. During the day, I'm well staffed with tier 3 analysts, and I can support that. But my night shift is primarily tier 1 analysts, right? They actually prefer the analysis coming out of Attack Analyzer because they achieve a high level of consistency in that analysis and definitely a pretty high quality baseline from that analysis, and feel like they're better protected and can sleep better at night because Attack Analyzer is doing the analysis or augmenting what their tier 1 team is doing. When it comes to their tier 3 team, they're probably going to want to engage with Attack Analyzer, not just for the automated analysis, but also use it to augment some of their interactive detonation and so on, where they may want to, reverse engineer a piece of malware, look deeper at it, and so on and so forth, even though Attack Analyzer has had a crack at it and told you it is malicious already, right? So I think we have a favorable comparison at large, and we do have a place that sits well alongside every SOC analyst, irrespective of what tier of SOC analyst they are at, in terms of augmenting their workflows. Scores of 70 and above, we feel pretty confident taking containment actions off of as an answer to your second part of your question. Jorgen asks, can the product be successfully deployed in non-internet connected environments? So Jorgen, ultimately, Attack Analyzer as a part of its analysis can operate in a manner where it's not connected to the internet. So we do allow you to disable internet connectivity when you're performing your analysis. That said, if your question was more about how do you get something over to Attack Analyzer, that would have to be connected to the internet, right? Because ultimately we need to receive your submission to API our API endpoint or our UI over a HTTPS upload, right? So you will have to have some internet connectivity for the rest of your stack, but in terms of analyzing the payload specifically, yes, we do allow you to disable internet, if that was the more of the spirit of your question. Matan asks, can we give manual steps to attack analyzer for specific type of attack, or everything is automated in attack analyzer? So there are a few knobs, and maybe I'll just go ahead and share my screen again, Matan, just so that it's more clear. So I'll go back into attack analyzer, and if you look at advanced mode here, there are a bunch of parameters that you can provide. For instance, you can specify which of these engines should be engaged, right? And these are all out-of-the-box engines that attack analyzer provides. You can also integrate it with other third-party engines that may exist in your environment. For instance, you have an EDR, you have some entitlement to a sandbox from that EDR. You can also configure that as an engine within attack analyzer to also get its opinion on things. This was the allow internet access knob that I was talking about in the previous question. Hope you can see that here. You can also provide like a password for a specific, specific file or archive that you're trying to have unlocked. More importantly, though, like we see attackers commonly engage in geofencing techniques. So we're able to help you specify the internet region that you would want to exit to that particular website you're trying to analyze from, so that you don't get caught up in the geofencing attacks. And then lastly, we are also seeing some level of device fencing, right? So we've seen QR codes, for instance, only render to devices that have mobile user agents. So we do provide those capabilities with an attack analyzer where you're able to go to a QR code with a specific mobile user agent. Some of that automation is built in by default, unless you specifically put in all of these knobs explicitly. We'll respect the knobs that you put in explicitly, but you can customize your user agent, etc. But those are some of the instructions that you can provide to attack analyzer. I hope that gives you a little bit more granularity on what kind of instructions you can provide. Going back to the questions, what is your take with AI when it comes to cyberspace in future? I see many dangers when it comes to AI. Can attack analyzer manage to filter and detect real-time threats that are formulated by attackers using AI? I think, Sifiwe, without getting sort of very broad on the answer here, right? I think, ultimately phishing is going to have tells, right? Like there's going to be, ultimately they're going to go after Microsoft credentials. So their page is going to look like Microsoft, right? And those are the kinds of things that we're looking for. Or from a malware standpoint, again, like there are going to be, certain things that, certain behaviors that they have to implement in order to exfiltrate data or establish communication with a C2 server. We feel like, those things will remain true irrespective. Yes, the velocity of it might accelerate even more. So we'll have to wait and watch. Is part of that equation, but I feel pretty comfortable about what we do and how I think we sit there. All right, I think I got through all of the questions here. Great engagement, folks, and lots of great questions. Did wanna go back to that resources section. So here are all of the resources that are available to you to get to learn a little bit more about Attack Analyzer and how it can help you with your existing Splunk SOAR or Enterprise Security entitlement to go further on your automation journey for TDIR. And then we do want to continue the conversation on community.splunk.com. We also are going to be part of an office hours session in early April. So if you would like to dive deeper onto this topic, would love to chat with you a little bit more. Apart from Vanessa, who I've decided we're going to follow up with, like if you have any other questions or if anybody would like a follow-up conversation with Splunk, a survey will pop up once you exit this presentation. We do ask you if you would like to engage with us in a follow-up conversation. So please do respond to that, and we'd love to reach out to you and get a chance to chat more.